Hello friends, I am Professor Dr. C.L. Ladekar from Pimpri-Chinchwad College of Engineering, Pune, and in this video you will see the impulse momentum principle. Very first is the impulse momentum principle. What it states? It states that the rate of change of momentum. Now the question is, what is momentum? Momentum is the velocity into the mass of any object. So if mass is more, the momentum will be more, or if the velocity is more, momentum will be more. So the momentum which gets changed, it's proportionate to the force which you will be applying. And how the momentum change takes place? It takes place, change takes place in the same direction as that of the force. Suppose, let us see here, you have one objective and it is moving with certain velocity v, and m is the mass of the object. So mv is the momentum. Now if its momentum gets changed at this position, suppose its momentum is m and velocity is v1, and at this position momentum is m v2. So what it means, that momentum got changed. Why it's changed? Because something externally. Suppose if you applied force from this direction, the momentum positively will change to the higher level of momentum. If you applied the force in opposite direction, the momentum of the body will get changed. Suppose if one vehicle is coming towards you and if you applied the counter force on that vehicle, okay, the momentum of that vehicle as well yours also get changed. But the momentum get changed, momentum got reduced if you applied in the counter direction. So mathematically, if you see the Fx, that is the force exerted, which is responsible for the momentum change, which you can calculate as the rate of change of momentum. And rate of change of momentum can be calculated if you see the difference in the momentum. So if initial momentum is something, final momentum is something, the difference of initial and final momentum will give you the change of the momentum. So Fx, you can calculate mass into acceleration. Mass into acceleration, ma, F is equal to ma. So Fx is equal to ma. Fx is equal to mass into acceleration. What is acceleration? It is the change of velocity. So force in a time. Suppose if you are applying force for a certain time, that will give you the mass into the change of velocity. Understood this? Now, if you are applying force, Fx for certain time period between t1 to t2, that will lead to change in the velocity from v1 to v2. It has certain mass, and the change in velocity that takes place from v1 to v2 when you are applying the force from t1 to t2 time. The impulse, if you calculate, it is the velocity v1 to v2 into m into dv, which you can say m into final velocity minus initial velocity, and impulse you can calculate as m into change in the velocity v2 to v1. So this expression is called as impulse momentum equation. This equation is called as impulse momentum equation, where it shows that how the impulse is directly responsible for the change in momentum, which you can in turn write mv2 minus of m Now if you write this in terms of the force is nothing but mass into the acceleration, which you can write in terms of change in velocity with respect to time. So mass per unit time into the final velocity minus initial velocity, that is the change in velocity dv. You can write F is equal to m dot, that is mass per unit time is the mass flow rate, m dot v2 minus v1, or you can write F is equal to density into discharge into v2 minus of v. So this force which you have calculated as rho q v2 minus v1, what it represents? This equation represents the force exerted by the body on the fluid. This much amount of the force will be exerted by the body on the fluid. And therefore, if you want to calculate the force exerted by the fluid on the body, you can take the negative, that is according to Newton's third law, the equal force will be applied by the fluid on the body. Therefore, you can calculate the force exerted by the fluid on the body. F is equal to minus rho q v2 minus v1, which in turn you can write F is equal to rho q v1 minus of v2. If you remove the negative sign, you can write this v1 minus of v2, or you can write that is equal to m dot v1 minus of v2, m dot v1 minus of. If u1 and u2 are the periphery velocities, so suppose there is a v on which the force is exerted by the jet, and the wheel periphery inlet is at u1, and the water which will be leaving from the wheel at an periphery wherein the velocity is u2. The power which will be developed when the water will be flowing from inside to outside with the periphery velocity v1 and v2, you can write power is equal to mass flow rate into velocity v1 into u1 minus of v2 into, and therefore power developed per unit mass, you can write v1 into u1 minus v2 into u2. So this you will be getting in terms of joule per kg or Newton meter per kg. What this expression represent? This represents specific work and is called as Euler's. So this is all about the impulse momentum principle. If you look at all the derivations and the terminologies which are developed or derived from this includes your impulse momentum principles and its mathematical expression. Then equivalent in terms of force exerted by the jet or the plate on the jet and the jet on the plate, as well you have derived the expression for the power and power per unit mass. This represent the Euler's. Now what are the applications of this principle? Here it is mentioned. This principle of impulse momentum is applicable in many cases wherein you are analyzing the forces exerted by the jet on stationary plates. It may be vertical, inclined, curved, may be acting centrally, curved plate acting tangentially, or it may be the force exerted by jet on the moving plates. Again, vertical, flat, inclined, curved with the tangential entry, or maybe the force exerted by the jet on the hinge plate, or it may be the series of the flat plate on which the jet is exerting his force, or maybe the series of curved plates wherein the force is acting tangentially. And the derived application of each of this, like wherein the tangential entry or to the curved plate on this principle the Pelton turbine is built. So you can derive this for this particular application, and similar kind of application like Pelton and the Bunky turbine you can use. So in the coming videos you will see the analysis of the forces on the various types of plate and the derivation related to that. So thank you very much for that.